Hello, my name is Leo. Today we're going to talk about some basic and frequently used algorithms in computer programming. The first two are max and min number algorithms. Let's take example of max number algorithm, which is used to find the maximum, the biggest number in some number sequence. Here we have example of number sequence of 6 numbers. So let's go. First we have to input n, which is number of numbers in this sequence, which is here 6 in the example. Now input the first number from the sequence, which is x equal to 3. Here we have also the big variable, which is variable in which we'll store the biggest number from this number sequence. And big variable is initialized to the value of this first value of x variable, which is x equal to 3. Now we go into for loop, which goes from 0 to n minus 1. It is n minus 1 because we've already input the first number of this number sequence. So here we have the second x input in for loop, x equal to 1. Is 1 bigger than 3? It is not. Then go into the next iteration of for loop. Then x is equal to minus 6. Is minus 6 greater than 3? It is not. Go to next iteration. X is equal to 6. Is 6 greater than 3? It is. Then big becomes 6. In the next iteration, x is equal to 9. Is 9 bigger than 6? It is. So big becomes 9. And finally, x is equal to 2. Is 2 bigger than 9? It is not. Then go out of for loop and print this biggest number, which is number 9. We can see that this big variable gets the value of x variable whenever x is greater than the value of big variable. Very similar thing is for min number algorithm, although here we have small variable instead of big variable, in which will be stored the smallest number from this number sequence, and we have the different if condition where x has to be smaller than value of small variable, so that a small variable gets the value of x variable. Sieve of Eratosthenes is an old algorithm which was invented by the old Greek mathematician Eratosthenes. So it is used to find prime numbers from some arrays, from some range of numbers. Here we have example of numbers from natural numbers from 1 to 100. And here printed all of the prime numbers from this sequence of numbers. And here is algorithm. So first we input the number of these numbers in sequence, which is here 100. Then we go into for loop, and for each of the numbers from 1 to 100, we want to know if each of them is prime or it is not prime. If we go from 2 to n plus 1, the beginning is 2 and not 1 because we know that 1 is neither composite nor prime number. And we go all the way to 101, which is not included, so the last included is 100. We assume in for loop that it is prime number. And firstly, we go to if statement where we check if the number is divisible by 2. So if it is even, if it is modulo by 2 equal to 0, and if that number is different from 2, then we can say that this number is false. So if statement was executed, then do not go to else and go to the next if statement in the for loop. So prime is false and anything else is equal to false, so this print within this second if statement won't be printed, meaning that any even number different from 2 is not a prime number. If we take for example 2, then the first if statement won't be true because 2 is not different from 2. Then it will go to else statement where k is round of sqrt of x. Sqrt meaning square root of some number. We know the rule from mathematics that a number is prime if it isn't divisible by any prime number which is smaller than its square root. So we have here square root, which is rounded. Square root of 2 is approximately 1.4, which is rounded to 1. And then we initialize m variable equal to 3 and go into while. While this number is prime, so while prime is equal to true, and while m is smaller than or equal to k, do this. So it is prime for now, because we've assumed that in the beginning of for loop, And is 3 smaller than or equal to 1? It is not. So while won't be executed, it goes out of the while, out of the else statement and into the second if statement. Well, where prime is true, is equal to 1, and x2 is greater than 1, so true and true is true, this number 2 will be printed, as we can see. This is the first prime number in this sequence. And let's, for example, take a composite number, number 9, which does not fulfill this first if statement because it is not divisible by 2, but then it goes to the else statement. Square root of 9 is 3, rounded is 3. M is equal to 3. Prime, while prime is, and this condition in while has to be fulfilled, it is prime for now. And is 3 smaller than or equal to 3? It is. So it goes to this if, which is inside while. And 9, is 9 modulo 3 equal to 0? It is, because 9 is divisible by 3. Then we can conclude that this command inside if statement, which is inside while, will be executed, so prime becomes false. So in the next iteration of while, this condition is false, it goes out of else to the if, but here is prime false, so the condition of the second if is false, and finally this number won't be printed. Euclidean algorithm is also an Old Greek algorithm which was invented by the Old Greek mathematician Euclid. It is actually an algorithm used for finding the greatest common divisor of two numbers, x and y. Here are also variables a and b, which are only variables not so important, used for storing the initial values of variables x and y. Here we have three different cases of these input numbers. First case are two co-prime numbers, meaning their greatest common divisor is equal to 1. Then we have two numbers whose greatest common divisor is equal to one of these two numbers, which is here 3, for 3 and 6. And final case, where are two composite numbers whose greatest common divisor is not equal to any of these numbers nor to 1, but is equal to 7 in this case of 14 and 21. So first we have in algorithm input x and y input numbers, then go to while loop. While loop is executed every time when value of y variable is greater than 0. And we have in each while loop iteration first print and last print. This first print prints the initial value of x and y variables before this operation. And after this operation we have also print for us to see the changes. And here we can see these pairs which are separated. So pairs of x and y variables, values of these variables. So this operation means that x variable gets the value of y variable and y variable gets the value of x modulo y. So remainder we get by dividing x by y by integer division. Let's take this first example of 7 and 5. X is 7, y is 5. Then x gets the value of y, so it becomes 5. And y becomes 7 modulo 5, which is 2. Then go to the next while loop iteration. X is 5 and y is 2. So x becomes 2, which is value of the y variable. Y becomes 5 modulo 2, which is 1, and so on. And we get in the end the x variable value is the greatest common divisor of these two numbers 7 and 5, while y variable has 0, value of 0, and this is why while loop has stopped with executing. So y value variable is not any more greater than 0. Now you've learned about some basic and very useful algorithms used in computer programming. Thanks for watching and stay with us.